Okay, guys. So today we are going to start with the third method to find out the order of reactant. So we people have done yet the two methods to find out the order of reactants. The first method was the experimental method. You are being provided the different experiments in a table, and you have to find out the order of reactant, make rate equations, K value, and the units of K. And the second method we have done, that was the graphical method. You have to draw the curves, okay, and you have to find out the order of reactant, okay, by half-life method or by drawing the tangent, okay, like that, okay. So if you people got any trouble in doing any question of the graphical method, you can send me the image of that particular graph in which you have completed the graph. Okay, so I will share that on the screen and will do the next part for you, because online I can't draw the graph and then put the values. You should send me the graph and I will do that question for you if you are stuck at some question. Okay, so today, my dear, we are going to start with the third method. Okay, so the third method, that is called as the uh, mechanism. This is the third method. So mechanism method. This mechanism method, that is the third method. Third method to find out the order of reactant. Okay, so now this time you are given some different informations, and you people have to work on those information and tell the examiner that is this first order, second order, or zero order. Okay, so let's discuss with that. Let's suppose, my dear, first of all, you got any of the reaction. Let's suppose you got a reaction. Now, please remember, whenever a reaction continue, it does not take place in in one step. It got different steps. The different intermediates, they are formed during the when the reaction is going to proceed. Okay, so every reaction has got different steps. Okay, so different steps. And these different steps, my dear, they are called as the mechanism. Mechanism. Okay. So in those different steps, keep remember the step which is the slowest step. Slowest step. So that slowest step, that is called as the RDS. RDS means rate determining step. Okay, so in every reaction, we got the different steps, and the step which is very slow, okay, which is the slowest one, that is always the rate determining step, RDS. Okay, now to make you people understand, I'm going to take one example up here. So I'm going to take one of the question and make you people understand, okay, about this question. So let me write a question up here. There is a reaction, okay. So the reaction is H2O2 plus 2I minus plus H positive. So that is going to form 2H2O plus I2. So this is the normal reaction. This is the reaction. Now this reaction, my dear, it does not proceed in that way. It takes different steps to complete this reaction. Okay, so how it is going to complete? So let me explain it to you. First of all, I'm going to write down the different steps up here. Let's go step one. Step one, that is H2O2 plus I minus is going to form IO minus plus H2O. This is your step one, and then you got the step two. Okay, in the step two, you got IO minus, which is formed up here. It is used in the next reaction, next step to form HOI, and then we got the step three. Okay, in the step three, this HOI, okay, plus H positive plus I minus, they are going to form I2 plus H2O. Okay, so now what I'm going to do, I'm going to make a rate equation up here in which I'm going to take H2O2, its order is A, and then I minus, its order is B, and then H positive, its order that is C. And here I'm going to take the three cases. Okay, so I'm going to draw a table up here in which the three cases they are present. So the cases, okay, so here is the numerical values. So this is A, this is B, this is C. Okay, so here I'm going to take different cases. So the first case I'm going to take step one is slow. Okay, guys, now everybody just listen this question. This question is very important. So everyone should listen it very carefully. First of all, this is this is the main reaction. This is the main reaction. Okay. So this reaction has got three reactants. One, this is two, and this is three. So three reactants are present. So the rate equation got all of these reactants. Sorry, I forgot to write up here A. A is equal to rate. This is the this is the rate equation I have made, but I did not write any value of these orders. Okay, now you are given these information. Okay, and he is going to ask you people. I'm going to suppose this reaction, this thing. If step one is slow, then what would happen? If step two is slow, then what would happen? If step three is slow, then what would happen to these A, B, and C? Okay. Now, the answer is very simple. I would tell you a story. Let's suppose one of my friend, okay, he's going to be married, okay, about 1 month later. Let's suppose, okay. So me and one of you people, let's suppose my student, we are given a task to write down the invitation letters, okay, and send them to different friends. Okay, so what I'm going to do, I'm going to write the invitation letter, and my student, he's gonna pack it, okay, and write the name of that particular person to whom we have to send. Okay, so let's suppose if I'm very fast and my student, he's very slow, so our work that wouldn't be completed. And if I am very slow and my student he's very fast, again our work that wouldn't be completed. Okay, so if any one of us that is slow, okay, the work wouldn't be completed on time. Okay, so the same is the case up here. We got the three steps of this reaction. These are the three steps of this same reaction. Okay, so what I'm going to do, I'm going to suppose these are the cases. I'm going to suppose step one is slow. Let's suppose this is the slow step, this is slow, and these are the fast step. Automatically, if he's gonna say that this is slow, so these are the fast step. Okay. Now in the slow step, whatever the reactants are present and whatever the moles they got, these moles would become the order of these reactants. If you look up here, H2O2, any one of you could tell me how much moles it got? It got 1 mole. So the value of A is 1. So you should write up here 1. Okay. Now I minus has got the value B. So here we got 1 mole of I minus. Okay. So it means B value is 1. So put 1 up here. The next thing, H positive. Okay, if you look in the first step, we haven't got H positive as a reactant. So it means H positive is not present up here. So the value of C that is 0. So we should put 0. Okay, so if over step 1 is slow, whatever the reactants they are present, in the slow step, those reactants, moles, they would become the order of this reaction. Did you get it? Yes, sir. Okay, so this is our step one. Now we are going to suppose the next case. In the next case, step two is slow. These are the different cases I am going to suppose. Okay. Okay. Now the next case I'm going to suppose that step two is slow. So this one is, my dear students, this time slow. So this is slow, and these two are the fast step. So this is fast, and this is fast this time. Okay. Now this is very interesting. Everybody just listen it very carefully. This is interesting. If step two is slow, so whatever the reactants we got, those reactants moles would become the power or the order in this trade equation. Now, if we look, we got IO minus. But if we look, we haven't got any IO minus up here. It's not the part of reactant. So it's actually the intermediate. It's actually the intermediate. Okay, so you have to find out from the previous step that from which reactants this intermediate that is made up of. Okay, so if we look back, IO minus, it was present in the previous step and it is made up of 1 mole of H2O2 and 1 mole of I minus. So this thing represents 1 mole of H2O2 and 1 mole of I minus. Did you get it? So this is intermediate. This is not the part of the reactant. So if such kind of the intermediate is present, so what you have to do, you have to look in the previous step that from which reactants it is made up of. So this IO minus that is made up of 1 mole of H2O2 and 1 mole of I minus. Okay, so it means it represents one mole of each of these. Okay, so you should imaginary. Just think about it that this is nothing imaginary. Okay, and this thing represents H2O2 and I minus 1 mole. So just write it in a small way. H2O2 1 mole plus I minus 1 mole. Okay, so H positive, that is the part of the reactant. So it's okay. So now what should you do? If you take step 2 as a slow, so H2O2 got 1 mole, H2O2 is not present, so 1. I minus only 1 mole is present, so 1. H positive 1 mole is present, so it got 1 as well. Online students, did you get it better?
Yes, sir.
Adia, all about the others, come on guys.
Yes, sir.
Okay. Okay, my dear. Now, the next thing what we are going to do, I'm going to rub this one. If you want to copy it, please just copy this one. Just take a screenshot of it because I'm going to rub it. Okay. Can I rub this one? Yes. Okay, my dear. So I'm going to rub this one. Okay. And now I'm going to take step 3 as the slowest step. So step 3 is slow. So if step 3 is slow, so then what would happen? So make this one as a slow step. This one is slow, and these two are the fast step now. So I told you the slow step contains the reactants. So those reactants moles they would become in the rate equation. Okay. So now consider up here HOI. HOI is not the part of the reactant. So it means this thing is intermediate. This is intermediate. Now you have to take this intermediate from the previous steps. So HOI that was made from these two. So HOI, it was made from IO minus and H positive. And IO minus, if you take this one is intermediate, it was made from these two reactants. So I have written these two reactants up here. So it means HOI, it represents one mole of each reactant. Did you get my point? So this HOI, it represents H2O2, it represents I minus, and it represents H positive. Okay. So this whole things they are represented by this HOI. Okay. So now if you want to put the value A, B, C, so H2O2 it got only one mole. So here you should write 1. Okay. So next is I minus. So I minus is present up here and I minus is present up here. So we got the 2 moles of it. So this is 2. And then H positive, H positive. So these are 2 as well. So my dear students, if the step 3 that is lowest, we got A value 1 because it got 1 mole. The I minus is present up here, it's present up here, 2 times it's present. So 2 moles of I minus, so B value is 2 and H positive is present up here, H positive is present up here. So we got the 2 moles of C, H positive is 2. Did you get it? So now keep remember my dear students, whenever you want to find out the order of reactant with respect to this mechanism method. Okay, whatever the step is slow, so just okay, just check that that is the slow step. Okay, whatever the reactants moles are present, they would become the order. But if unusual thing is present, so this is the intermediate, and check out this intermediate is made up of from these two. This is also intermediate. It is made up of from these two. So 1, 2, and 3. So three reactants, they are made up of this HOI. So you should write these 3 reactants 1 mole. Okay. So in this way, you can calculate the order of reactants. So you can take the screenshot of this question, please. Okay, beta. So everyone just look that question. I'm going to do that question for you. Okay. So have a look up here. I'm going to read this question for you. First of all, the question is saying, this is another type of the way in which he can give you the question. Have a look up here. He's saying, the reaction is found to be first order. Beta, nazar aa raha hai? The reaction is found to be first order with respect to this one and with respect to H positive and zero order with respect to I2. Okay. यार राजू तुम्हारी वजह से भाई वेट कर रहे हैं तुम क्या बन रहे हैं. Okay, so by looking at this information, we can make the rate equation. So what I am going to do, I'm going to make the rate equation up here. So the rate equation rate is equal to K, and then he said this one got first order. Okay, so this one got first order. So CH3 COCH3, it got first order, and H positive got the first order as well. So first order with respect to H positive. And he said zero order with respect to I2. So I2 zero order, so it won't come in the rate equation. Did you get it? Because if anything is having the power zero, it would become equal to one, and one when multiplied with any number, so one would be finished. Okay. So this is the rate equation, my dear students. Okay. So now what I'm going to do, have a look up here. This question is very interesting. So he has given you these four mechanism in the question, four mechanism, and the rate equation I have given you up here. Okay, so these are the four mechanism, and what the question he is asking, decide which mechanism is consistent, explaining the reason for your choice, mechanism A, B, C, or D. Okay, so this rate equation got one mole of this one and one mole of this one. So it means in the slow step, one mole of these two things could react with each other. So first of all, we have to see the slow step. This is the slow step. In this slow step, we got I2, but here I2 is not present. So it means A is wrong. In the B, the slow step, this is the slow step, it got one mole of CH3CO, CH3, and this one got one order of this one. And it got one mole of H positive, it got one mole of one order of H positive. So it means this mechanism B that is consistent with this rate equation. And what the reason you should write in the rate equation, we got one order of CH3, COCH3 and H positive. And in the mechanism B, we got one mole of CH3, COCH3 and H positive in the slow step. So that is why the above rate equation is consistent with this mechanism. If you look at third C1, why it's not C? The slow step contain the intermediate. So intermediate contain these things one mole, but I2 also contain one mole. So it means I2 is not present in that rate equation. So that is why it is wrong. In the next one, the slow step contain these two things. So one mole of this one, it's okay. But one mole of I2, we got one mole of H positive. So this is wrong. So D is also wrong. Did you get it? So if you look up here, these kind of the things are present in different questions. See, he has given you the different mechanisms like that. Whatever the rate equation you should make from the above information, that could be applied up here. Okay, the same type of the question. Okay, but first of all, you have to make the rate equation by using the above information. Okay, so let me tell you one more type of the question he could give you in the paper. Yeah, this is the question. So everybody just look at this question, beta. Have a look up here. This is the main reaction. This is the reaction he has given you. Okay. This is the reaction. And the second information he is giving you the rate is first order with respect to NO and F2. So you should make the rate equation by yourself. Rate is equal to K. NO got first order. Okay. And F2 got first order as well. This is the rate equation. He said the reaction mechanism has two steps. So suggest the equation for the two steps. So it means we should make the two steps. First of all, the step one. Okay. So the two steps. In the first step, one mole of this one and one mole of this one should react. So we should take one mole of NO and one mole of F2. So that is going to form, if we look, the main reaction, the product is NOF. So you should write NOF. So whatever the thing is left, one F is left. So you should write one F up here. You can write it like that, or step one, you could write it like that. NOF2, that's your choice, whatever the thing you want to write. Okay, so NO and F2, you can write it like that, NOF2. So these things are actually the intermediates. Okay, and then you could make the step two. Okay, in the step two, if you have taken this one, so you could write F radical. So we got the two NO in the main reaction, take one more NO, and we will get NOF. Okay, so this one is consistent with that. And if you take this one, okay, so you could take NOF2 and you got one more NO up here. So NO, So it would become 2NOF. Okay, this one is consistent with that. So that's your choice. You can make any, and this one, that is the slow step, and this one, that is the fast step. Or you can write this one as slow step and this one fast step. So I've given you the two ways to write down the equation. Okay, so in the rate equation we got one mole of these things. So you could react one mole of these two things and write the product according to your choice. That's your choice. You can write it like that, or you can write it like that. That's your choice. Okay, so if you write this one, so use this equation now, fast. Or if you use this one, you could do this one as a second step. Did you get it? सिर्फ फास्ट और स्लो नहीं है। जी फास्ट नहीं, अपनी मर्जी से नहीं, ये भाई वन मोल है ना। तो जिस रिएक्शन में एक एक मोल इनका रिएक्ट कर रहा होगा वो स्लो स्टेप है, तो वो यहाँ पे कर रहा है वन, या ये भी वन मोल है, तो ये दोनों तो एक ही है ना। मैंने बताया ना कि दोनों में से कुछ भी ले लो। ठीक है, पता चल गया। ऑनलाइन स्टूडेंट्स डिड यू गेट इट? अगर दो दो मोल होते फिर भी स्लो ही लगेगा। अगर दो दो मोल्स तो होंगे नहीं भाई, इक्वेशन में इसके दो हैं और इसका एक है। नहीं वैसे वैसे सपोज कर रहा हूं, अगर किसी इक्वेशन में जी तो वो दो दो मोल ले लेते हैं। तो केस में स्लो होगा कि फास्ट? कौन सा? अगर दो दो मोल है, अगर सपोज करो कि यहाँ पे तुम्हें वो कहता है कि इसके दो स्टेप हैं, तो वो दो मोल्स होते, तो तुम जब पहला स्टेप बनाते तो उसके साथ 2NO ले लेते और 2F2 ले लेते, इस तरह करके। अगर रेट इक्वेशन में दोनों के साथ टू टू लिखा हुआ है, सपोज कर लो NO का ऑर्डर 2 है और F2 का भी ऑर्डर 2 है, सपोज करो, तो इनके दो दो मोल्स लेके वो रिएक्शन करवाते और ये स्लो स्टेप होता। ये सपोज कर रहा हूँ भाई, स्टेप या इस तरह का एक और क्वेश्चन आता है जी वही है। ओके गाइस, दिस इज द नेक्स्ट क्वेश्चन, ये डी पार्ट। इफ यू लुक एट दिस डी पार्ट, ही इज सेइंग the following sequence of step is a proposed mechanism for the reaction. So this is the main reaction, this is the reaction, and it got two steps. This is step 1 and this one is step 2. Okay, he's saying the general form. So he made the rate equation for you. He said step 1 is slow, so this one is a slow step, this one is a fast step. So in the slow step you got 2 moles of X, so it means the M value is 2. In the step 1 you haven't got the Y, so put 0 up here. So this is 2 and this is 0. Did you get it? बट साहब हर चीज देख के पता चल रही है यार, ये वो तुम्हें क्या कह रहा है, स्टेप 1 स्लो है, तो भाई स्टेप 1 ये स्लो आ गया, ये स्लो है, ठीक है। तो तुम्हारी स्लो स्टेप में एक्स के कितने मोल्स हैं? 2। तो भाई ये एक्स के ऊपर एम लिखा हुआ, तो एम की वैल्यू 2 आ गई। ये स्लो स्टेप के अंदर आपको वाई लिखा हुआ नजर आ रहा है, वाई लिखा हुआ नजर आ रहा है, स्लो स्टेप में आ रहा है, कहां पे आ रहा है, हाथ लगा के बता सकते। स्टेप 1 में कहां पे वाई है? तो भाई मैं स्टेप 1 में पूछ रहा हूँ, वो तुम्हें कह भी रहा है कि स्टेप 1 इज द स्लोवर स्टेप। तो स्लोवर स्टेप में जो रिएक्टेंट्स हों उनके जो मोल्स हैं वो रेट इक्वेशन में आती हैं, तो वाई यहाँ पे मौजूद ही नहीं है, सो इट मींस दिस इज 0, तो दिस इज 0। यू गॉट इट नाउ? या दिस इज द क्वेश्चन। Okay guys, if you look up here, this is the main reaction, this is the main reaction. Okay, so he said is first order with respect to ICL, so make the rate equation, rate is equal to K, ICL got first order, and first order with respect to H2, so H2 got the first order as well. Okay, so now, my dear students, what should you do? He said, suggest the mechanism for this reaction. Okay, the mechanism has 2 steps, so you should make the 2 steps. So what should I do? Here we got one mole of this one, so take 1 mole of ICl and 1 mole of H2. Now see the products up here. The product we got HCl, and what is being left? The left thing is HI. If you look, HI is not present in the product in the main reaction. So this HI is the intermediate, use this one, this is the slow step. So use this HI in the next step. Here we got 2 ICl. So 1 ICl is still used. Take another ICl in the second step. This is the fast step. Okay, so we got HCl, HCl, and I, that would become I2. So these are the two steps, my dear. Okay. So it's not necessary that you should write the products like that. You can make your own products. Okay, it's not necessary that you should make the intermediate in that way, whatever I made. You can make the intermediate like that. ICl plus H2 1 mole. So make this one like H2ICl. So this is the intermediate. Use this intermediate H2ICl plus ICl 1 more. So this one is going to form HCl plus IO2. So you can write it like that. This is slow and this is fast. So that's your choice, whatever the products you want to take. Okay, guys? Yes.